Hello everyone, I welcome you all to this next video in the Spring Framework lecture series. We have come towards the end of this series. Next we will learn Spring Web. The concepts we are learning in the course series forms the base for more advanced concepts that we will learn in upcoming lectures. In the previous video, I used the concepts of component scanning to get rid of manual bin definition. Later on, I used auto-wiring to demonstrate how to auto-wire bin dependencies to form a cohesive application. Component scanning and auto-wiring are very powerful tools available to us which can simplify the application configuration metadata a great deal. Going forward, I will not be using manual bin definitions and bins wiring. In this video, I will cover following topics. Number 1, application environment. Number 2, internationalization. Number 3, container extension points. So without wasting any time, let us get started. If you haven't already, please subscribe to the channel, like the video, and share the content as much as possible. The first one is application environment. In the context of computers, the environment refers to the system conditions an application is running in. Some examples of system conditions are the operating system, number 2, Java runtime version, number 3, system environment variables, number 4, network infrastructure accessible to an application, number 5, disk storage or disk access, number 6, databases. These are some examples of system conditions. There may be other system conditions as well. For example, on which cloud you are deploying an application, while AWS is comparatively different than Google Cloud. Broadly speaking, an environment can be thought of as a digital space with computer servers and network infrastructure. Some examples of digital spaces are: an organization may have a QA environment where the developers test their code before production release. An organization always has a production environment which hosts the true running copy of the application. The production environment is the one where mass users interact with your application. Different environments may have different system conditions. One example of different conditions is a development environment database is different from a production environment database. Spring Framework has an environment abstraction which models two key aspects of the application environment: profiles and properties. Let us have a look at both of them in detail. First, let us understand profiles. A profile is a named logical group of bin definitions to be registered with the container only if the given profile is active. As we can see, profile A is active, so profile B definitions are not registered with the container. The role of the environment object with relation to profiles is in determining which profiles are currently active and which profiles should be active by default. To understand profiles practically, let us consider the use case of different databases for different environment. To define a database, you define a data source bin in your configuration like this. To have different databases for different environments, you typically will have two different bin definitions. One should be active in production environment and another one should be active in QA environment. The problem is, how would you switch between them based on the current environment the application is running in? This problem is solved by bin definition profiles. We can use the profiling to categorize bin definitions within one profile or another and then activate the specified profile. How does profiling work? We can use the profile annotation to indicate to Spring that a component is eligible for registration only when the specified profile is active. The profile annotation can be used in three ways. We will have a look at each one of them in the next section. The first one is on any class directly. We can add the profile annotation to any component class including the configuration class as shown here in this example. If the profile annotation is added to any component class, Spring will make sure to register such components only if the specified profile is active. If the profile annotation is added to any configuration class, then all the bean methods within that configuration class will be eligible for registration only if the specified profile is active. Next is using profile on bean methods. We can add profile annotation on any bean method directly. When the profile annotation is added on the bean method, Spring will register such bean definition only if the specified profile is active. Finally, profile annotation can be used as a meta annotation. We can use profile annotation as a meta annotation to create more specialized custom annotations like QA profile or production profile. We can then use these annotations in place of profile annotation. Now that we have defined our components based on the profile, we still need to instruct Spring which profile is active. The most straightforward way to activate a profile is to do it programmatically using the Environment API. Most often than not, we will not be initializing application context ourselves, hence we can also declaratively activate profile using the spring.profiles.active property. The property accepts a comma-separated list of profiles to activate. This property can be specified either as an environment variable or as a JVM system property while starting the application. Do note, profiles are not an either-or proposition. You can activate multiple profiles at once. Default profile. If no profile is specified by the developer, Spring by default has a default profile. The name of the default profile is default. All the configured beans are activated in the default profile and they are accessible from the Spring IOC container. Next, let's have a look at properties. So the first question that should come to our mind is, what are properties? Properties are key value pairs used to configure an application. Properties are always associated with an application and they describe various aspects of an application. Some examples of properties are database URL, database username, database password, and so on. Application properties may include some business properties as well. For example, in our application of sending out communications to users, we have to send out max 100 communications. In that case, we can have a property max communications to restrict the maximum number of communications sent to a user. This will prevent spamming from our end. Properties may originate from variety of sources. Number 1, properties file. Number 2, JVM system properties. Number 3, system environment variables. Number 4, custom sources. Number 5, database tables, and so on. The role of the environment object with relation to properties is to provide the user with a convenient service interface for configuring property sources and APIs to retrieve property values from them. Let me talk about properties infrastructure within the Spring framework. Properties are always associated with a property source. Property source is a generic class which we can extend to specify a custom source of properties. Multiple property sources can be defined and they are combined into a single entity using the property sources interface. Mutable property sources is the default implementation of the property sources interface and it combines multiple property source implementations in a list as shown here in this animation. Property Resolver is an interface which provides APIs for resolving properties against any property source. Spring environment interface extend from property resolver interface, thus making sure that property resolver APIs are available via environment object. The default implementation of property resolver is property sources property resolver, which is initialized with a property sources implementation. Whenever a user requests for a property, it searches within its secret property sources to find the property value. Adding custom property sources. The entire property infrastructure provided by Spring Framework is configurable. This lets us define our own custom property source, which we can add to the list of property sources using the environment. Here on the left, I am defining a custom property source, and on the right, I am adding it to the environment object. We can also use the property source annotation on any configuration class to add a property source to the Spring environment. Property source annotation must always specify the resource location from where to read properties file. Here, in this case, all the key value pairs present in the application.properties file will be added to the Spring environment. Fetching property values. We can use getProperty API of the environment object to fetch property values. Spring allows us to dependency inject the environment object into any other bean. We can also implement the environment aware interface to get access to the environment object. We can also use the value annotation to inject property values directly into the class field. The search performed for a property value is hierarchical. So, if a property is defined in multiple property sources, the one with the higher precedence wins. System property value has higher precedence than environment variables. Note that property values are not merged, but rather completely overridden by a preceding entry. Let me talk about default environment implementation and default property sources in the Spring framework. Spring has a standard environment implementation of the environment interface, which is used for the generic application type. For specific application types, there are other implementations such as standard servlet environment for web applications. Spring's standard environment is configured with two property source objects, one representing the set of system environment variables and another one representing the set of JVM system properties. The full hierarchy for a common standard servlet environment is as follows, with the highest precedence entries at the top. We will learn more about property sources and hierarchies in the Spring Web and Spring Boot lecture series. While declaring the property values, we can also add placeholders as shown. The value of the placeholder will be resolved by Spring. Here, in this case, Spring will search for database user property value within its existing configured property sources. If the property is present in any one of the configured property sources, its value will be used to replace the database user placeholder. If the value is not present, Spring will throw an exception as it will fail to resolve the placeholder value. We can also use the placeholders when declaring property source resource locations or in XML bean configurations. Next topic is internationalization. We will continue on this topic in part 2 of this video. My apologies people, I have to cut short this video here as I don't want it to be an information overload. Part 2 of this video is coming very soon. As always, thanks for watching. Do subscribe to the channel and share the content as much as possible. I will see you in the next one.